Hello friends, I welcome you in lecture number 20 on logic. In this lecture, we are going to discuss another method of finding principal disjunctive normal form of a given statement formula. In previous two lectures, we have seen how we can use truth table to obtain principal disjunctive normal form. But if we have more than two variables if we have a very lengthy formula, then using truth table becomes uncomfortable or tedious. So instead of truth table, we can use some logical equivalencies to obtain the principal disjunctive normal form of a given formula. And now we know that principal disjunctive normal form is nothing but disjunction of mean terms or sum of mean terms only. Sum of mean terms only is called principal disjunctive normal form. So we will try to write given formula as a sum of mean terms. Now before going for this method, we just recall some logical equivalencies. Suppose we have some statement variable, say p, and if we take p or its negation, then this is always a tautology, and that we can denote by capital T. Similarly, if we consider p and a statement which is a tautology, then this is always equivalent to small p or whatever variable we are using. Here I have used capital P, so I will write capital P. So mainly we are going to use these two logical equivalencies, and we are going to use distributive laws also, and commutative laws also, and this also we know that if we have p or p, then this is equivalent to p. So using all these logical equivalencies, we can obtain principal disjunctive normal form of a given statement formula without using truth table. So this we explain using this example. I have taken two statement formulas and I will obtain principal disjunctive normal forms of these two statement formulas. First one is negation p or q, and we can see this is not in principal disjunctive normal form. This is disjunction, but it is disjunction of negation p and q. Negation p is not a mean term. Similarly, q is also not a mean term, and principal disjunctive normal form is nothing but disjunction of mean terms. So we will try to adjust mean terms in between, and that we are going to do here. So first what we can do is we can use this logical equivalence. We can write p is equivalent to p and t. Therefore we can here write negation p is equivalent to negation p and t, and or as it is. Similarly, q is equivalent to q and t. So whenever I have only single variable, to obtain mean term I will start with this. I will consider negation p and t, which is always equivalent to negation p. Similarly, q is equivalent to q and t. Now we require mean terms here. So what we can do is, now we can replace capital T by q or negation q. We know that q or negation q is always equivalent to capital T, and because I have variable p here, I am writing q or negation q. Here I have variable q, so here I will write p or negation q, p or negation p. Again we repeat, we want to obtain this obtain the principal disjunctive normal form of this formula. So here we can see this is disjunction of negation p and q, but negation P is not a mean term. Similarly, Q is also not a mean term. So to obtain mean term, our first step is we use this fact that negation P and T is logically equivalent to negation P. Similarly, Q is logically equivalent to Q and T. Now here variable is P, we are using negation of P here. So for capital T we will replace it by Q or negation Q, and we know that Q or negation Q is always equivalent to capital T. Similarly, here variable is Q, therefore we will write T logically equivalent to P or negation P. Now we can use this distributive law. Here we have AND operator, here we have OR operator. So using distributive law, this I can write as negation P and Q, or in between, and negation P and negation Q. Similarly, I am using distributive law here also, or is in between. Here I can write Q and P, or Q and negation P. So what we have used here, using this we have written using distributive laws. Here also we can write, here we are using the fact that P or negation P is logically equivalent to capital T, and here we are using this fact P and T is logically equivalent to P. Now we will see that if we have identical mean terms, then using commutative law we will ignore them. Here I have negation P and Q, so I will check here whether there is another negation P and Q. So there is another negation P and Q here. If we use commutative law, then negation P and Q and negation P are logically equivalent. So we can ignore this negation P and Q. Then negation P and negation Q, that is not repeating. So here I keep this as it is, negation P and negation Q, or Q and P, that I can use, that I can rewrite as P and Q. So what we have used here, using commutative laws, and we are using this fact also, that if we have P or P, then that is logically equivalent to P. So using commutative law, negation P and Q and negation P are same. So we will have negation P and Q or negation P and Q, that I have written as negation P and Q. Okay, again we repeat, here I have negation P and Q, and here I have OR operator, and using commutative law I can rewrite Q and negation P as negation P and Q, and now I have used this logical equivalence. So this is logically equivalent to negation P and Q. So whenever we have identical terms, we will ignore and we will write only one time. Now we can observe that all these are mean terms. We can see these are three mean terms using variables P and Q. If you recall, the four mean terms for variable P and Q are P and Q, P and negation Q, negation P and Q, and here negation P and negation Q. So you can see negation P and Q is here, then negation P and negation Q, and P and Q. So this formula is nothing but disjunction of these three mean terms, and therefore it is in principle disjunctive normal form, or it is principal disjunctive normal form of given formula. So in this way we can use truth table, and we can easily write down principal disjunctive normal form without using truth table, not truth table. We consider another formula and we try to convert it into principal disjunctive normal form. Now first we have to observe the number of variables in a given formula. Here we have 3 variables p, q and r in a given formula. Therefore our min terms will be consisting of 3 variables p, q and r. In above formula here we have 2 variables p and q. Therefore we have tried to write down min terms out of these 4 min terms. So whenever we have only single variable, we write down q or negation q with negation p, and here I have only one variable, so I have written q and p or negation p. Now if we have 3 variables, then we will make sure that in min terms we try to obtain 3 variables. This is, you can see, this is in disjunctive normal form. This is nothing but sum of elementary products p and q, negation p and r, q and r. All these are elementary products and we have disjunction operator in between them. So this formula is in disjunctive normal form, but it is not in principal disjunctive normal form because it is not disjunction of min terms for 3 variables p, q and r. Therefore we have to find out principal disjunctive normal form for this. Here which variable is missing? R is missing, here q is missing and here p is missing. So first thing we will do is we can write that p and q is logically equivalent to p and q and t. Same thing here, negation p and r is logically equivalent to negation p and r and t. Then here q and r is logically equivalent to q and r and t. And what we have used, we are using this simple fact that p and t is logically equivalent to p. Now in the next step we will use this formula that if I have p or negation p, then that is logically equivalent to capital T. Therefore we can replace capital T by appropriate variables. Here we have 2 variables p and q, so I will replace capital T by r or negation r. Then in this second we have q missing, so this we can rewrite as negation p and r, and this we will write as q or negation q. Or in the third bracket p is missing, so we write this as q and r, and t is logically equivalent to p or negation p, and bracket complete. Now we use distributive laws, so we will consider p and q with this. If we wish, we can write in the bracket also p and q and this. Similarly negation p and r, here q and r and this. So now using distributive law I can rewrite this as p and q and r, or operator in between p and q with r, and p and q with negation r, or operator in between. So here I write p and q and negation r. Same thing we do for second bracket. We apply distributive law, negation p and r and q, negation p and r and q, or operator in between negation p and r and negation q. Then q and r and p, again we apply distributive law, q and r and p, or q and R and negation P. So this we have written using distributive law that I will mention in the bracket. This is using distributive laws of logic. Now we check whether there is any min term which is repeating. Here I have P and Q and R, and I will check whether there is P and Q and R somewhere here. So this is nothing but P and Q and R. Using commutative law we can rewrite this as P and Q and R. So we will ignore this. Then we check for this P and Q and negation R. So I will check here. I will check for P first. So this is not repeating. Then negation P and Q and R. So negation P and Q and R. So you can see this is repeating. Negation P and R and Q. Using commutative law we can show that these two are equivalent. So we will not write this also. And negation P and negation Q and R, that is also not repeating. So we have now these three min terms only, P and Q and R, or P and Q and negation R, or negation P. This I can rewrite as negation P and Q and R. If we consider the order for PQR as first P, then Q, then R, and using commutative laws. Or this I can rewrite as negation P and negation Q and R. Now we have all these are min terms for three variables P, Q and R, and we have OR operator in between. So this is nothing but principal disjunctive normal form. And what we have used here, we have used commutative laws as well as this logical equivalence. P or P is logically equivalent to P. Here we have used that fact. P and Q and R, this is also P and Q and R using commutative law. So we are using that fact here. P and Q and R or P and Q and R, that is logically equivalent to P and Q and R. Therefore we are not writing it two times. So this is principal disjunctive normal form of a given formula containing three variables. So all we have to remember is that if we have three variables, we will make sure that we are using min terms containing three variables as a disjunction, and we will use these formulas. P and T is logically equivalent to P. P or negation P is logically equivalent to true, and whatever variable is missing, that we will write for capital T. Here I have written capital T equivalent to R or negation R because P and Q are present here. Here negation P and R are present, so Q is missing. Therefore I have written Q or negation Q in place of T. Here P is missing, therefore I have written P or negation P in place of T. In fact, I am using this logical equivalence, and I am using distributive laws, commutative laws, and this logical equivalence, which we can call as idempotent law also. So this is another method of finding principal disjunctive normal form of a given formula, in which we are not using truth table. Instead of that, we are using all these logical equivalences. P and T is logically equivalent to P. P or negation P is logically equivalent to T, and we are using distributive laws, commutative laws, as well as this formula P or P is logically equivalent to P. So in this way we can obtain principal disjunctive normal form of a given formula without using truth table. So this is all about this session. Thanks for watching.